a large number of different things that you will learn. One of the important thing that you to learn, actually there is a big difference. When you buy a petrol tank is what? A steel box or maybe even an aluminum box, container, that itself does not cost much. Then you fill it up with the petrol, it is a petrol that costs. But when you talk about electric vehicle, you have a battery. Actually, battery costs huge amount. And then about electricity that you put in. Electricity cost actually is not large. It's actually for the same amount of energy far less than petrol. We will talk about it, we will learn what it is. So, there is an upfront cost of battery, whereas in petrol vehicle upfront cost of tank is very low. It comes is bundled with the vehicle. The bundled with the vehicle comes a large battery, and that battery containers of cost is very high. So, this is a capital cost, upfront cost, but we actually use it all the time. We fill electricity, we charge it, what we call, and then we use it, discharge it. Then we again use it, again discharge it. We keep on doing it, and one of the thing that you learn, that after some time battery capacity will keep on going down and battery becomes useless. This does not happen in petrol tank. Petrol tank, the capacity will remain whatever it was. Battery on the other hand has a certain life. You will have to replace the battery. So, large upfront cost, suppose you gave 100,000 rupees for a battery. Every time I filled in 1 kilowatt hour and used it, how much will it cost? Actually, this is a fairly complex calculation, not done, not understood very well. I am actually paying upfront, but I am using it over maybe 4 years. For every kilowatt hour, what is the cost? And this involved calculation we will learn to deal with it. We have to actually find out how many times can I charge, discharge, what is called cycles, that is called life of a battery, how many times can I charge, discharge. Then I have to actually, I have paid already for that. So, how do I take into account what I have already paid? Well, I have to take something called depreciation and something called finance cost or interest. Interest, most of you understand. You borrow something from the bank, you have to pay interest rate. So, you assume as if this battery has been purchased from a loan. Interest rate, whatever the bank charges, that is the interest rate that you have to account for. What about the money that you have borrowed? You have to return that money over 3 years, 4 years, 5 years, whatever time, for the life of the battery you have to return the battery. That term, that how much of that battery cost has to return year after year is called depreciation. In some sense, battery value has reduced. It started with 100,000, maybe after a year it has gone down to 80,000 rupees. And after that it may have gone down to 60,000. This is a depreciation rate. The economic terms used is depreciation. There is very easy way of calculating depreciation and interest, and we will teach you. And the depreciation has to be for the life. By the time the battery becomes useless and I throw it, that time I should have returned that. So, when I buy a new battery, I have to can take a fresh loan. So, we will have to understand the life of the battery, we have to understand then the depreciation, we have to understand interest rate. And what will be the operation cost? Operation cost of course, will be the fuel cost, cost of electricity, which I told you is there, but does not play as important role, but we will have to take that into account. And can we combine all of this, and can we learn how to compute what is, as if I have not paid anything upfront, what is the cost of usage of 1 kilowatt hour of electricity in a car. Then only I can compare it with petrol. How much is the usage if I am using, let us say 0.2 liters for a kilometer. I know straight away the cost. In my petrol cost, let us say 80 rupees, 0.2 liter will cost 16 rupees, and for a kilometer it is 16 rupees. For battery and for charging, I have to first take depreciation and interest rate of the battery. That will give me the battery cost, plus I have to take the cost of electricity, and this will give me a kilowatt hour of usage cost, and we will learn how to calculate this. Now, are there other costs? For example, somebody may say, are there environmental costs? For example, we burn petrol. Is there an environmental cost? It is ignored. We do not somehow pay for that. Same question can be asked, once the battery gets over, its life is over, electricity per se does not cause this direct impact on environment. Indirectly one may say generation of electricity has impact, we will deal with that separately. But battery, once it is over, you throw it away. Is it a waste? Is there environmental impact? We will deal with that also, but it is often ignored. So, similarly one can say, are we going to use electricity from coal? Then there is an environmental impact of the coal also. Or if I am going to use it from solar and wind, the environmental impact is very different. Our objective will be tomorrow to use battery which is fully recyclable, which does not have an impact on the environment, and electricity from renewable energy, solar and wind, such that the electric vehicle becomes fully renewable energy. That is what, and we will learn in this course what we have to do. It is not easy, but it is very much doable, and this is one of the things that we have to do. To just get a feel of it today, the cost of a battery, somewhat large size battery, not a very small battery, is about 12,000 to 15,000 rupees per kilowatt hour. This is a capital cost for let us say 5 kilowatt hour battery, maybe around 60,000 to 75,000 rupees per kilowatt for 5 kilowatt hour. We will actually learn how to compute this, what does it really mean, we will learn each of these things in detail. This is what I have done as a part of first chapter. I will now move to the next chapter. Do you have any questions on the first chapter? It is the first section of the first chapter. I have not finished the introduction. We are now going to get a little more in depth into the vehicles in India, and my proposition is that India needs to drive its electric vehicle program differently and innovatively to scale. And the reason is, if we look at the characteristics of Indian vehicles, there are two characteristics that you will find that small vehicles dominate. Number two, affordability dominates. Therefore, our vehicle requirement is different from that required in let us say Europe or United States. So, since we are going to introduce electric vehicle where battery is going to be a large cost, one has to actually deal with even the electric vehicles, keeping in mind that we need small and affordable vehicles. So, just to look at it, look at the number of vehicles that were sold in different year from 13-14 to 2018-19, and look at the later 18-19, and you see that almost 80% of the vehicles are two wheelers. That is not so in most of the countries. Then there are 3-wheelers, e-rickshaw has not been included here, others would have been a little more. And then there are some commercial vehicles, and then there are cars. So, the cars are only 15%. That is the first thing that you will notice. Most of it is 2-wheelers. Okay. The second aspect that you will see, and 3-wheelers are very important, because they have become the last mile transport or public transport for most people, because buses are there only in limited number of cities. A lot of people actually travel by 3-wheelers. So, 3-wheelers are very important. Now, if I want to look at these cars, passenger vehicles, cars, which is about 14 to 15%, here also look at the numbers. If you look at, this is in percentage, if you see 27% of the vehicles cost less than ₹500,000 or 5 lakhs. 57% of the 56.5% of the vehicles cost between 5 lakhs and 10 lakhs, which is between ₹0.5 million to ₹1,000,000. So, if you look at it, almost 84% vehicles are less than ₹1,000,000. And even if you go above ₹1,000,000, ₹1,000,000 to 1.5 million, you still have only 14.65%, and very few 1.5% or even less than that above ₹1.5 million. The reason I am emphasizing is that if you go to Europe or United States, the lowest cost car will exceed this ₹15 million, which is about $2,000, $20,000, about $20,000. They will be above that. Whereas in India, either it is a 2-wheelers or 3-wheelers or cars which are low cost. That is the dominant percentage of vehicles. And I put it out here, if I look at in India, 2-wheelers, the autos and small goods vehicles and economy cars costing less than ₹1,000,000, it will be about 95% of the vehicle. And the India's strategy has to be, it is this market that we should capture and we should win, we should be ahead of others, our vehicles should be better and yet low cost, similar to the costs that are today people are purchasing. The reason our affordability is low simply is because our economy GDP is low. They can only afford that much amount. You can't push them and say, oh, now buy more expensive vehicles. They will buy the same 40 to 50,000 rupees to 60,000 rupees 2-wheeler and ₹500,000 to 0.6 million, 0.7 million rupees for 4-wheelers. That is where the dominant market is. And our electric vehicles has to more or less match that numbers. That is what has to be done. And it is this that we should become very good at, and we should become the world's best. And for the higher end vehicles, well, it does not really matter, we can learn from the West, we can borrow from the West, we can adopt what they are doing. I think they are doing some excellent work. There is let that happen largely as a transfer of know-how from the West. But for small vehicles, we have no option. The other very important question will be the same question which I asked earlier. EV's cost of capital cost, when we talk about 500,000 rupees car or a 50,000 rupees 2-wheeler, and the operation cost, the cost of energy per kilometer. Now, one thing that you will notice right in the beginning, that without battery, electric vehicle cost will be less than a internal combustion engine vehicle or petrol vehicle. As soon as you include battery, the whole scenario changes. Expensive battery to store energy. So, battery is extra cost and dominant cost. Therefore, a significant part of the battery cost, our thinking, our focus will be how to reduce that cost. There is a very interesting slogan that captured the imagination of people in India. It was a slogan that was given by Maruti for its cars. And the slogan that was given was "Kitna deti hai." Must have heard about that. How much? What is the mileage? Why was that slogan caught the imagination? Because for a middle class people who want to buy the vehicle, the cost of petrol was really pinching. And if it gave larger mileage, more number of kilometers per liter, cost will come down. And that caught the imagination. Most other manufacturers also focused on what is called energy efficiency. So, the mileage or energy efficiency, the mileage term became common to energy efficiency. What is the equivalent term and does it really matter? We will show you it does matter. The equivalent term for us is watt hour per kg, per kilometer, sorry, watt hour per kilometer. How much energy is used per kilometer of travel? What will happen? If I have better watt hour per kilometer, sorry, less watt hour per kilometer, if I use less watt hour per kilometer, my size of the battery required becomes smaller, and if the size of the battery becomes smaller, my cost goes down. So, focusing on reducing watt hour per kilometer. Remember earlier we talked about watt hour per kg, that was the property of the battery cells. Here it is a different, it is a property of vehicle. Can I consume less energy to travel 1 kilometer? How much watt hour per kilometer I travel? Lower it is, lower is the size and weight and the cost of the battery. Now, if I have a lower size cost, lower weight, there is another thing happen. The energy efficiency of the vehicle depends on the weight. How much watt hour per kg depends on the vehicle weight. Now, the vehicle weight of course is the weight of the vehicle per se, the people, the luggage and everything else, plus the weight of the battery. Weight of the battery is considerable. If I have a smaller weight battery, my energy efficiency improves, watt hour per kilometer improves. So, it has a double effect. First I reduce watt hour per kilometer, that means my battery size becomes smaller. Once my battery size becomes smaller, my watt hour per kilometer further goes down. Therefore, to make electric vehicles viable in India, I will say the first technology program, first R&D program is how much can you reduce watt hour per kilometer, or start asking the question for electric vehicle, kitna deti hai? This is something that was not understood for a long time. Actually, it is not as significant for the West, this question. Why? Because the affordability is much higher. In fact, kitna deti hai Maruti slogan came in India and not in Japan. It becomes advantage in India. So, even for electric vehicles, the question that we have to ask, kitna deti hai, instead of a liter of petrol, we talk about a kilowatt hour of battery. That is the first thing which will efficiency improved by improving. And how do you improve this energy efficiency? Simply improve the efficiency of motor and controller. That helps in improving. How do you improve further? Better tires. Better tires help. We will talk about it. We will show what is called a rolling resistance. If I get a tire with lower rolling resistance, it improves the energy efficiency. Better vehicle aerodynamics. Aerodynamics will play a very important role in the energy we consumed, and we will actually calculate if I improve my vehicle aerodynamics, which it improves the energy efficiency. And of course, if I reduce my weight. How do I reduce my weight? Well, I can't reduce the people weight, I can't reduce the weight of the luggage that they have, I can only reduce the weight of the vehicle. Can I use different material to reduce the weight? Of course, reduce the battery size, that reduces the weight. So, this the program for the, we know how to improve energy efficiency or kitna deti hai or watt hour per kg. There are 4 things: improve efficiency of motor and controller. This will be one of the major focus in this course. Better tires, not the major focus of this course, but that we want to know. Better vehicle aerodynamics, again we will not get into detail of vehicle design, this is not a course of vehicle design. And lower weight, which to some extent means, can I improve my battery, my watt hour per kg, improve the battery efficiency. This is what we will try to do.